Welcome to the Explainer. Now, I want you to picture a modern container port for just a second. You've got these massive steel ships, towering automated cranes, and thousands of metal boxes being shifted around with absolute mathematical precision, right? It's literally a marvel of physical engineering. But behind all that physical reality is a digital one, and honestly, it is entirely fractured. We constantly hear that AI is going to totally revolutionize global trade, but if you look closely at international customs today, that revolution is heavily stalled. So why is that? Well, that is the exact mystery we're unraveling today. Okay, let's dive right into this. We definitely have a tendency to think that if we just go out and buy a smarter, more expensive AI model, all our supply chain problems are just going to magically vanish. But the reality is that the data layer, not the AI model itself, is the true bottleneck here. The core paradox of modern customs is that artificial intelligence is absolutely ready for deployment right now, but our global customs data infrastructure is fundamentally broken. We're essentially asking a 21st century intelligence to read through 20th century paper trails, and it just doesn't work. So here is our roadmap for today's explainer. We're going to start with the AI data constraint, then we'll diagnose a major flaw called the relationship gap. From there, we'll introduce the global customs canon, examine its key tool, the trade line assertion, and finally, we'll look at what true AI-ready trade actually looks like. Let's kick things off with Section 1, the AI data constraint, and exactly why better algorithms aren't enough. Let's just bust this myth right out of the gate. Simply plugging a better algorithm into a customs agency does not magically fix all the bottlenecks. Take a look at this hard metric on screen, 7 percentage points. That right there is the improvement in seizure rates achieved by China's Tianquan targeting model. And get this, they did it without increasing the volume of physical inspections at all. It's a massive leap forward. But research tells us this level of performance only really happens when the underlying data is heavily structured. It shows us what AI is actually capable of when the conditions are right, and it sets a real benchmark for what customs modernization should be aiming for. Despite those localized successes like the Tianquan model, overall AI performance in customs is what we call architecturally bounded. What does that actually mean? Well, it means the ceiling on your AI's intelligence is strictly set by the structure of your data. Right now, most AI in customs is kind of stuck doing basic administrative chores. It's spending all its massive computational power just trying to extract text from messy, unaligned PDFs. It's doing document translation instead of actual risk inference. It's literally like hiring a world-class detective, but then making them spend all their time translating the case files from 5 different languages before they can even start looking for clues. Moving right along to Section 2, the relationship gap. This is where we diagnose the structural flaw in the system. This brings us to a really absolutely crucial definition. The relationship gap is the structural absence of machine-readable connections between core trade documents. Think about it like this. A commercial invoice tells you what was bought, right? A physical packing list tells you exactly where it is, down to the specific pallet, and a regulatory certificate of origin tells you where it was made. But today, these documents are floating completely independent of one another. They're in totally different universes. They don't mathematically reference each other in any way that a computer can automatically understand. And this comparison brilliantly hits the nail on the head. On the one side, you have a human broker who looks at these isolated documents and uses context, years of experience, and human intuition to mentally connect the invoice to the physical pallet and then over to the regulatory rule. They bridge the gap right there in their minds. But on the other side, the AI parser, it completely lacks human intuition. It just sees disconnected, inert data fields. Without explicit, machine-readable relationship data linking those fields together, the AI is completely blind to the larger context. Which brings us to Section 3, the Global Customs Canon, the public infrastructure for trade data. Take a look at this excerpt from the Canon's architectural specification, specifically focusing on stages 4 and 5. What this explicitly shows us is that true automated AI risk scoring is, well, it's mathematically impossible unless the underlying data is structured, shared, and explicitly governed across agencies. You simply cannot just jump straight to stage 5 AI risk scoring if your foundation is just a giant pile of unstructured PDFs. The Canon acts as the master blueprint to actually build that necessary shared structural layer. So, the Global Customs Canon provides this 5-layer graph-first architecture, starting from the OWL2 knowledge graph all the way down to the WCO data model binding. But hey, you don't need to be a software engineer to grasp why this matters so much. Just think of this architecture exactly like TCP/IP for the internet. Before TCP/IP, different computer networks literally couldn't talk to each other. But once that foundational infrastructure was laid down, the modern internet just exploded. The Canon is that exact same kind of foundational semantic infrastructure, but built for global trade and AI. All right, Section 4, the trade line assertion, otherwise known as the canonical junction object. Let's see how this builds together. The trade line assertion, or TLA for short, is the specific tool that finally closes that relationship gap we were just talking about. It acts as a canonical junction object, basically a digital knot that explicitly binds 3 crucial things together at the individual piece level. Step 1, it grabs the commercial invoice line so we know exactly what was bought. Step 2, it links that to the physical piece like a pallet barcode so we know exactly where it is. And step 3, it binds both of those to the regulatory credential so we legally know where it was made. By firmly binding these 3 dimensions together, the AI finally gets the complete context it needs. Now, what makes the trade line assertion such a real game changer is that it shifts our entire architecture from twin dependency over to data sufficiency. You see, a lot of times in supply chain tech, people will say we absolutely need a perfect digital twin, like a complete 3D digital replica of every single product on day one. And honestly, that's incredibly expensive and insanely hard to scale. But the TLA says, no, we don't need a full digital twin. We just need data sufficiency. We only need the highest confidence data package required for customs to operate legally and efficiently in real time. It is highly pragmatic, and for sure, it's highly scalable. And that leads us right into our final section, Section 5, AI-ready trade administration and the graph-first inversion. Okay, so this architecture sets up some incredibly strict boundaries for artificial intelligence. Because, let's face it, if a customs agency denies a shipment, they have to be able to legally defend exactly why in court. An AI just hallucinating a random answer? Yeah, no way that holds up. So, the Canon mandates what's called intentional AI role separation. Shackle protocols strictly enforce what data is admitted. Sparkle comes in and retrieves only the hard facts. OWL2 derives the logical, mathematical conclusion based purely on customs law. And the large language model, its only job, literally its only job, is to explain that strict logic to the human customs officer in plain, everyday language. The AI never guesses, it only derives determinations from explicitly governed facts. So, the crucial point we are arriving at is a monumental shift called the graph-first inversion. For hundreds of years, global trade has been built entirely around document. The piece of paper was the absolute source of truth. Well, the Canon inverts this entirely. In this new architecture, the relationship between the data points, the knowledge graph itself, is the primary source of truth. The legal documents, the customs declarations, the commercial invoices, they are merely derived outputs. They're just printed out from the underlying graph whenever a human actually happens to need to read them. And that brings us right back to our core thesis for this explainer, summarized perfectly in this quote from the source material. The AI improvement follows automatically when the architecture is correct. Think about that. If you actually invest your time and money into fixing the data infrastructure, closing that relationship gap, and implementing smart tools like the trade line assertion, you don't have to worry about constantly coaxing a language model to do better. The reliability, the speed, and the true intelligence of the AI will emerge completely naturally, all because the foundation is finally solid. So, I want to leave you with this final thought to chew on. Whether you're a policymaker, a technologist, or just someone fascinated by how global logistics actually works, are we going to keep spending all of our energy trying to magically coax better answers out of AI models? Or are we finally ready to build the data infrastructure that AI actually needs to do its job? The Global Customs Canon gives us the exact blueprint. Now, it's just up to us to start building.